Agents. I'm Rene. I'm the co-founder and CEO of Casco. And before this, I was a head of product at AWS and also worked for a long time at Microsoft. A little bit about myself is I've really been fascinated with AI for a very, very long time. I like to claim that I invented, oh no, is the video loading? Internet, please, come on, participate. Oh no, 1 second. It did say? Let me do one more run at this. It's just different if the video plays. Yeah, there you go. All right. It's loading, Okay, come on. Fingers crossed. Oh God. All right, see, there's baby Rene here, 11 years ago, winning Europe's largest hackathon with a voice-to-code agent I was building back then. And you could talk to it, have it create a website, and then you could have it load in images and whatnot. It was just such a fun time with AI. Back then it was only classifier models and whatnot, and it was a lot of different cloud providers strung together just to support this thing. And it was just so cool. And so I've always been fascinated with this entire space. It's this really cool tech that you can build there. Obviously, since then, many things have changed. I hope, I look a little bit older, a little bit more experienced. And I also quit my big tech job at AWS, moved into a garage with my co-founder to do the classic startup thing. And we got into Y Combinator. And so, wow, that was super fun. It's okay, cool. Now it's time to build a startup on our own, and we're building a security startup. So what do we want to do now that we're building a startup? We need to launch. So how do we have a really cool launch post that we want to create together? So we thought maybe we should just hack all of our batchmates. And so we looked at what is the setup of the agents back then and how did the architecture evolve, right? Back then, I had to strung together 4 or 5 different cloud providers, talk to all these different systems and whatnot. But there's actually this normalization now of the LLM agent stack, right? So nowadays when you're building an AI agent, you have a front end that talks to the back end. Your API server's talking to an LLM and all this kind of stuff, right? And we notice that when we talk about security in the agent space, we often only talk about LLM security, which is really that part there, where API server goes, talks to the LLM, you check for prompt injection, that kind of stuff. But if you worked in security long enough, whenever there's an arrow, you should probably check if that arrow is secure. You can talk threat model and all that stuff, but it's really just, boxes and arrows. So we realized there's a lot of issues all over the place, all over there. And our company really focuses on all of that. And so we decided, let's figure something out there. Let's figure out the security posture of different AI agents in our batch. So as I mentioned earlier, we tried to hack our agents because we really wanted a flashy headline. I'm not going to lie, that's why we did it. And we were okay, we also don't want to waste too much time doing this. So this is how we actually set up our process. We're okay, we're going to set up a timer for 30 minutes. And then basically for 30 minutes, try to hack one of our batchmates. And there's 16 different AI agents as part of our accelerator program. So I was okay, we can go through it over a weekend. I think this is a good time spent. And the hypothesis is that we can somehow go from there to company compromise. We somehow get the system problem and it will get us to getting access to your entire company. And then we spent some time identifying different risks, what are the different capabilities that the agent have, and then try to exploit them ultimately, right? So if you have ever done pen testing, this should feel familiar and is basically the regular pen testing process. And it has worked, turns out, phenomenally well. So there was 16 agents as part of our batch. We hacked 7 of them with 30 minutes each. And there's actually 3 common issues that I'd like to walk you guys through today. All right? Cool. So the first one might not be a surprise to folks, but it's around cross-user data access. So when you work with an AI agent, you can often ask it to fetch documents, fetch information from a conversation, start building up the context to be more helpful for you. But what's interesting is, for example, with this company, we're we extracted their system prompt and we found out there's a lot of reference by ID kind of capabilities. Whenever you see something's being referenced by ID, this might be weird. What if I just put in another ID? Let's see. And so the obvious thing is like, okay, this could be like an IDOR attack, but in the agent space. What if you just prompt the agent to use different IDs from other users to fetch information? So in this case, they were trying to fetch some sort of messages, right? And today, we just see many people just authenticate the request, check if the user token that's making the request is valid, but never actually check against if the record is supposed to be belonging to that end user. And yeah, it turns out we found a demo video of the founders online. And from the browser URL bar, we were able to extract an ID from their demo video. And I was like, hey, give me information of this user. And yeah, it surely returns everything. So that's pretty awesome. And then the agents are so helpful. They're like, hey, you know what? I'm also connected to not only their messages, but also like their documents. So you can then start now crawling information through this one particular identifier and access all of their information. Isn't that crazy? I was like, wow, that's kind of cool. I mean, cool for me, yeah. And so for folks who don't know this, the way to do it is to authenticate and authorize. That means, check if a request is actually allowed to be made in the first place. Are you an authenticated user? And then also tie it in with some sort of like row-level security behind your request. So you're making sure that that particular post ID actually belongs to this particular user, so you can actually fetch that information. If you're using any sort of like out-of-the-box systems, like a lot of founders I see use Supabase these days, it's actually built in. You just got to use it. It's like literally one flip of a switch. And it will get rid of a lot of these problems for you. So authenticate and authorize. Now, this was kind of like a problem in that arrow, right? It's like, I kind of already jumped over the whole, we did prompt injection thing and so on and so forth, because like prompt injection is kind of a means to an end. It's more like a reconnaissance of like what the agent can do, but the damage is all happening behind here, right? And I think that is really the focus area that we all need to like wake up to when we are talking about security testing AI agents. And so the thing that we need to remember is that agents actually act like users and not API servers. Like it's like when we talk to all these founders, like, you've kind of solved this problem before with web applications. Why are you making this mistake with AI agents? And it's just purely because as developers, we like to pattern match. We look at, the thing is behind the API server, so this is like an API server, but it's not true. It is actually like a user. It's like a virtual user of your product. And so all the things that we do for web application security, sanitizing your inputs, making sure the authentication is properly scoped, all stuff actually applies too, right? So it is like this mindset shift that I think everybody in their organization needs to kind of flip as well. It's like, it's deploying on the server, but it's a user, actually. It's a user. And so that is like super, super important. Agents act like users, despite them being inside an API server. Now, that means a quick rundown of lists that agents should not be doing. So they should not determine their own authorization model, like with just passing IDs for reference and whatnot. They should not act with service level permissions, like global read-only access roles. That happens all the time. Go back and check your software. Or accept any arbitrary input, or forward any output without sanitization. Those things are all things we have learned to do with end user data when they use your web app. You just got to do them too for agents. Mindset shift, right? Okay, cool. So that leads us to the second set of issues that we've seen. And this is more specific to AI agents. And I'll give you a little bit of a precursor of what this means, like BATS code sandboxes. So here's an Anthropic paper that I thought was very interesting. I think it was published a little bit earlier this year. And it basically talks about the AI usage and the broken down by the industry. So you can see there's like, the graph is kind of like all skinny on the left side there, and then with like one outlier. So who's this, right? Okay, it turns out it's us. It's like, hey, computer, mathematical, hey, that's us. Hey, you guys all use AI every day, hopefully, right? So, this tool is very useful for us. And it turns out that there's not only, it's not only for that purpose that it's good, helping you write code or, generate a payload for your pen test or something like that, but also a lot of the AI capabilities use coding tools under the hood to perform tasks that are deterministic. It's like, we all know agents suck at math, right? You want to do a calculator, you actually have the agent run some code in the background. and run that in a code sandbox, and then gives you the result back, right? And that can stretch from like a simple math calculation to things like running SQL queries, you know, and doing a bunch of other things. So it's like, okay, there's something interesting there, right? And a lot of different tools, even if they don't tell you they're using a code sandbox in the background, they still are, right? Even if it's not a coding agent, right? Like a recent one I've seen is like a financial accounting agent that just needs to run a lot of spreadsheet calculations, right? They're not going to tell you it's like a coding agent or something, but it's going to run it in the background. So this is really about this little arrow here, where your tools of your LLMs actually kind of start talking to a container. And whenever you have like willingful remote code execution, there's like something interesting to look at, right? And so it is also something that people tend to underestimate and kind of roll their own. So we started looking into some of these agents that had those capabilities. So kind of back to our approach, we extracted system prompt. All right, now let's read through exactly what the developer told us not to do. All right, okay, so when editing files, never output code. Okay, so we need to output code to the user unless requested. Okay, okay. Instead, use one of the code edit tools at most once per turn. So what if we just use it twice per turn? Like, what happens? Like, the interesting thing with system prompts is it actually downloads almost like the brain of the developer into text, and you can kind of see all the things they don't want you to do. So all you have to do is like do like an inverse map of that. So it's like, okay, so I'm gonna do exactly that, watch me, right? And you can find a lot of interesting issues through that. So with this customer, we're like, okay, let's try to output code all the time because I really want to know what's going on. And then also just hijack the agent to run multiple turns instead of just one. And it was kind of interesting. We tried having it like run a network request, create a reverse shell and whatnot. It's like, God, this company is so smart. They only allow me to write Python code, and I'm team JavaScript. Sorry, guys. And then they don't allow these really dangerous imports, and also they restrict which Python files can be run. And on first glance, it might be like, wow, they've done a good job. There's something interesting here, like but nothing to exploit. But there are two permissions they allowed, which are kind of like innocuous. It's like you can either write a Python file, to execute, and then also you can read files. It's like, all right, okay, so we cannot do all these crazy imports, but we can write files and read files, write files and read files, write files and read files. What can we do? Let's take a look, right, in the file system. What's going on in this container? What's going on here? Well, it turns out there's this app.py file. I was like, oh, that's interesting. Oh, and that app.py is kind of the control plane for the sandbox. That means it receives all the requests and be like, oh, yeah, okay, now I need to write this file, and so on and so forth, right? It's like, okay, so this is a system file. If we can somehow like figure out what to do there, that might be interesting for us to look into and modify. So, okay, these. Oh, these protections. Guys, have you seen this? Wow, and they're all like nicely documented for me. Isn't this great? And so, okay, so I can just like comment all this out by writing a new app.py file. And then I run it again, and remember on the second turn, then all of these protections are gone. So by nature now, you have access to the code sandbox. So we can go Bitcoin mining. Let's go, right? It's a rough economy this year. Obviously, that's a joke, guys. Don't do it. Obviously, this now creates an environment for us to do remote code execution. And whoever has ever done this before knows it's really, really fun. Obviously, for on this side of things, it sucks for the company. But there's a lot more things you can do once you're inside a machine, because like. Machines are kind of not like isolated, right? They're not like alone on a network. There's probably more to it, So has anybody ever dealt with like metadata endpoints in cloud environments? Has anyone done that? No one? Okay, one person. All right, cool. Super good information to have. You can basically do a discovery call inside your cloud environment, like this customer was using GCP, to check, oh, what's kind of my project ID, guys? Like, what are other things that are in this network? Because there's like legitimate reasons for cloud providers to expose that so that computers can connect with each other and whatever, right? And the other endpoint that's really good is to check, what does my service role actually have permissions to, right? It's like, oh, if you've ever worked with any cloud provider ever, you know that setting up permissions, IAM permissions, is probably really hard. And whoever has ever been in an environment where everything is set up perfectly? All right, yeah, so exactly. And because of that, well, it turns out this thing has big query access, which is like this way to query big data inside Google Cloud. And it turns out that's where they had all their customer data too. So now, through this really badly coded sandbox, we're able to do network discovery, figure out what are other endpoints available, right? And then realize, oh God, we have access to their entire customer data. That's scary. And so now you can also siphon out all that customer data from there, right? And it's like multiple layers of failures. It's like peeling an onion. The more you peel, the scarier it gets, actually, right? And also, it will make you cry at the end. Yeah. So, yeah, bad code sandboxes really cause damage. TLDR: don't roll your own code sandbox. Like that's my appell to everybody. The parallel I would draw is like when we were working on, web apps was a super hot thing for a long time. People kind of were in the same spot with auth for web apps. And this saying of like, don't roll your own auth kind of came along and generally was pretty good advice. I think we're going to see that with agents too. Like, there's going to be many people that are going to start building AI agents thinking they can quickly build a code sandbox, but are not aware of like all these other complexities involved, right? And the correctness around those systems. And so just like we don't roll our own auth anymore in web apps, we should not roll our own code sandboxes. And so there's a few providers here that you guys can check out. They're all pretty good. And E2B is also open source, so you guys can actually self-host it and whatnot, right? So there's a lot of good stuff there. And this is just something that we have noticed that typically when customers have used a managed code sandbox environment, they basically have a shared responsibility model, obviously on security with them, and it tends to be more secure. So that's issue number 2, and we can go to issue number 3. All right. So the third one is around these tools. Like, these tools accept a lot of inputs. It's kind of cool. Tools are used for like asking the agent to do some deterministic things, to get some data, write some data and whatnot. And it turns out a lot of them, you can lead to server-side request forgery for them. This is kind of interesting setup too. So that's really this little bit over there, that arrow, where a tool can call some external data sources. Now, kind of following our same principle, this is like a coding agent that we looked at. And it had a very cool capability. Like, this is like earlier in spring. They were very unique in a set of capabilities because they could allow you to create databases alongside your front end. So your applications were actually useful and not just a UI. It was a super cool app. And it turns out they have this very interesting capability over there where the database schema is actually pulled from a private GitHub repository based on a specific branch. And oh, it's just a URL, right? That's cool. And so if you can already hijack agents to extract their system prompt, if you can hijack agents to make any sort of arbitrary tool call, what is the natural thing you want to try to do? You would obviously try to like put in some request information into there. Like, what if you just called it with some other information? What if it's just like a honeypot server on my own domain, and I can actually receive the credentials to their private GitHub repository? Because remember, this is a private GitHub repository, right? Oh, okay. So, and then, kind of back to the same story as before, I don't think anybody ever sets up proper repo permissions either, just like they don't set up proper cloud permissions. So using the GitHub token, you can actually start downloading their entire company's source code now from there too. Right. Obviously, this was really bad. This is like this honeypot server. It includes this Git credentials in there. And you can just say, clone it from badactor.com and siphon out all that information from it. But this one was actually kind of funny because we found it, and literally a minute after, I think, it was like 5:20 p.m. or 30 minutes after, he was like, oh, we already actually fixed this. Like, so they were already onto it, luckily. But it's like, like this kind of, it's always these kind of little innocent things where you're like, oh yeah, I want my users to have, ability to, set up their different database schemas and whatnot. That suddenly lead to, my entire company's value prop is open source now too. And so it's a little bit funky. And so it's something to just really take into account as you are building your software and building these agents. All these arrows really matter across the board. So always sanitize your inputs and outputs. Always sanitize your inputs and outputs. Always sanitize your inputs and outputs. That is just repeat that to yourself. Always sanitize your inputs and outputs. Just whew. Okay, it's like part of my evening meditation at this point. And so this is like the three big issues I wanted to walk you guys through. And a lot of these things happen because like AI is happening. The timelines are very aggressive, and you need to hit your Q3 quarterly goals on AI delivery. And so some of these things are just not thought of in the moment, and we need to take a second to really internalize that, and so that when you are launching new products, new agentic features, that they're actually not only useful to your customers but also communicate trust of your company. And so three key takeaways I want everybody in this room to have. The first one is agent security is larger than LLM security. Like I skipped over the whole prompt injection thing because I think there's a lot of talks on that and it's really good. But really think about where the damage can be happening, and it's on all the other arrows. Keep thinking about all the other arrows, right? And then treat agents as users. That applies to this off. Sanitize your inputs and outputs, right? Like just keep thinking of them as users. They're users. They're users. They're not APIs. They're in the API, but it's not a user. It's a user. It's a user. And then the last is they're obviously don't roll your own code sandboxes. That always is like a little sketchy, like to have that properly configured. Use an open source solution. There's many good ones out there I called out today. So you can really be set up for success. Yeah. So that's everything that I wanted to talk to you about today. And if you want to chat more with me, you can connect with me on LinkedIn. I'm everywhere, Rene Brandel, just like my first name, last name together, on LinkedIn, on GitHub, on Twitter. That's it. Any questions? Do we do questions here? Yeah, we do questions. Okay, cool. Yeah. All right.
Were there batch feeders that you couldn't get into?
We time capped it to 30 minutes. So yeah, so I think out of the 16.7 were hacked, so the other 9 were, took longer than 30 minutes. Yeah. Oh, I will do that. Okay, cool. Any other question? All right, up there. So the question was, did I use prompt injection to find the code sandboxes control plane server, basically, the app.py file? No. So I used prompt injection to just understand what tool capabilities it had, write and read. And then actually I asked the agent to write a tree function over their file system. And then through there, printed that back to the user and then saw which files look suspicious. Yeah. Oh, by the way, one advice, because this is relevant. If you guys are ever dealing with a coding agent, the best way to build a reverse shell is to ask the coding agent to build you a terminal UI that is functional. It is absolutely beautiful. Anyway, sorry. They do the work for you. I love AI. Anyway, sorry.
You as a developer, because in security, this is what we always hear. Oh, they didn't set this up right, or that wasn't set up right. Is there a way to set it up right, or are we just accepting that we're shipping out stuff that's insecure? Like, do we ever get to a point where it's like, here's how you do it, and you're done? Or
yeah. So the question was like, if there are always things that are not set up correctly, is there going to be a path towards having everything set up correctly, right? That's what it boils down to. So I think the way I look at security is like it is a set of toolboxes, right? There's many things you can do statically beforehand and analyze. And what has been bugging me, what has compelled me to start this company is really realizing that there's this toolbox that I think we all really like, which is a penetration test. But it's been cost prohibitive for most companies in the world, right? It's actually the ultimate, test if your system is secure, can go through. And today people can do it like once a year, maybe for $10,000 a pop, right? Something like that. But if we can build AI to do that penetration testing for us and do it really well and shrink down the iteration time and actually increase the frequency and make it cost accessible to most company, it would just become another tool just like your static code analysis tools, right? And that, in combination with these existing static tools, I think will really change the security landscape. And so my mission is to make all software effortlessly secure. Yeah. Cool. Okay, then.
In your third example with the SSRF,
Yeah.
just to clarify, you're able to extract the key credential from the FQDN,
Yeah.
Sorry, from the FQDN.
Yeah, so the question, I guess the question was if we can clarify what was the information we extracted from the SSRF attack on the tool?
And the GitHub repo, I guess, would be
Yeah. Yeah, exactly. So there's a few prerequisites here. So the first one is that the GitHub repository was private. So if I just hit the URL, nothing would happen, right? So in order to access this private GitHub repository, you need some sort of Git credentials associated to it, right? So if the tool has access to that, then if you can somehow get that bit of the header that has the Git credentials, then you can now replay that attack locally, right? So we basically set up a honeypot server, like our own kind of GitHub, our own Git server on our own domain, and then just tricked it to make the request to that domain instead of to GitHub. But still, the tool was implemented in a way that regardless will always encode that header information there. So then you can extract the header information from there and then replay the attack. Yeah. And then you can obviously download the rest of their source code and whatnot. Yeah. Cool. Awesome. Yeah.
Sorry, just follow up. So if they use SSH auth for that, would it have prevented that, I guess?
I haven't looked into that. In this case, it was an HTTP request. Yeah. All right. Oh, up there?
Really like what you did replacing the actual PI.
Mm-hmm.
But like, it's not a critique of dynamic languages, but you could probably have written all those block statements, for instance, by just writing more creative Python code. You basically assemble Python code in your uploaded code and call all those things, right?
Mm.
Dynamic languages are extremely challenging for security situations like this in general.
Yeah. Yeah, so I guess the question is there are other ways to exploit the particular code sandbox server? And I think if I would up-level that question, and the answer is yes. And I think that's why bad code sandboxes are really dangerous. You should not roll your own code sandboxes. It's just a can of worms, right? All right. Cool. Awesome. Thank you so much.